It's part 2 of the reproductive system, beginning with the male reproductive anatomy and physiology. And we were looking at this diagram right here. And as you can see, the testes descend through the inguinal canal on either side, and they occupy completely different, how shall I say, little encapsulated areas here, and well defined, so they don't have interaction with one another. These would have been, had it been of the female development. There's a lot of homology between male and female, and so the soft tissue right here in the female would have been labia majora and minora. So in a sense, these testes are going down into the labia majora or minora, and then it's enclosed in the middle because we don't need a vestibule here, a vaginal vestibule, because the urethra is going through what in the female would have been a clitoris, and in the male is an elongated clitoris, in this case the penis, and so the glands up here is surrounded by a prepuce, and you can see all of these details. You'll notice that the testis is carrying with it, when it comes down through its descent, it's carrying artery, veins, and a plexus of veins that are referred to as the pampiniform venous plexus. It has its testicular artery. It has a ductus or vas deferens for sending sperm to the tune of hundreds of millions up through this way. There's an autonomic nerve coming down to regulate everything here, including the position of the testis. On a hot day, it's a little bit further from the body. On a very cold day, it's snuggled up close to the body so that it can pick up the heat of the body. So there's variations on a theme. The sperm is being created for the purpose of travel outside the body. So the fact that we're developing sperm that ideally work at a temperature slightly less than 98 degrees Fahrenheit is important, because it's going to be traveling out through the penis into a vaginal space, which is going to be also a little bit cooler than body temperature. If you're the physician who's doing the general exam in the male, you're placing your finger here at the external ring, and you're asking your patient to turn his head and cough, and you're checking to see if there's a little bit of pressure against your finger there to determine maybe this person has an inguinal hernia. Okay, not to be confused with a femoral hernia. Okay, we come over to this diagram here, and we see the position of the testis in relation to its spermatic cord. Here's the testis, here are the seminiferous tubules, and the seminiferous tubule walls are actually the site of primordial cell initiation and development. So the primordial cells begin down here at the very edge of the wall of the seminiferous tubule. This is cut in cross-section, and there's going to be mitotic figures down here in which the primordial cells are dividing into daughter cells, and the cells are percolating up. When that's complete, when we actually have the sperm development into a spermatozoa, we don't see it so much in this picture, but or in this picture, what we need to bear in mind is that there are some extra cells in here which are surrounding the developing spermatids or spermatozoa. Those cells are referred to as sustanticular cells. And where are we pointing to those here? I don't see them pointing. Oh, here we go. Here we have the seminiferous tubule and the sustanticite, or I call them Sertoli cells, because there was probably an Italian gentleman named Sertoli that named them, and or sustanticular cells. So they're the sort of the nurse cells that surround each of the developing sperm as it's developing and feed the sperm. And so there is a blood testes barrier created by the tight junctions between these cells right here, the nurse cells. Ultimately, the nucleus collapses. We call it becoming pycnotic. The nucleus collapses at the very end. The sperm tail emerges out here. I don't really see any good ones for us to look at, but I can see right here. Do you see them? Here's the nuclei of the sperm that are collapsing into little arrowhead-like shapes, and eventually they'll grow their flagella out here, and then they'll back out of the driveway. And they won't be able to swim, so they'll just have to float at this point. And the fluids of this part of the anatomy are flowing this way, this way, this way, this way, and they're coming to this thing over here called the rete testis. And so there's this sort of like little region through here that the sperm have to cross, the rete testis, and then they're going to come over here to these little coiled portions here of the epididymis. This is the head of the epididymis here, where we have the initial stages of sperm maturation. So even though the sperm are initiated in the testis, they're first synthesized, they are not matured nor are they stored until they get to the epididymis. And there's several more weeks to go here of biochemical development. And eventually they have the capability of swimming. And they percolate down, down, down here to the end and to the tail of the epididymis, and then we have the very beginnings now of the ductus deferens. Okay, so ejaculation can occur from even the depths here of the epididymis. All right, just the way you like it right there. So then there's another detail in this picture that I overlooked and we need to address. There's these interstitial cells right here, and here they're called interstitial cells, and they're these are the primordial cells. These are also called Leydig cells, and so these interstitial or Leydig cells are between the seminiferous tubules. And let's see, they're right about here. And you can see the nuclei look a little different. They have different cytoplasm. These are actually stimulated by the luteinizing hormone from the pituitary, anterior pituitary. So let's take a look here. Here we are at the anterior pituitary, and we're putting out luteinizing hormone, and FSH is follicle stimulating. Follicle stimulating will actually activate the primordial cells here in the seminiferous tubule. So we're going to activate primordial cells to produce sperm, and that's the province of FSH. LH is going to act upon the Leydig cells or interstitial cells to produce testosterone, and that's going to be the work of in the province of luteinizing hormone. Okay, so I gave you a little biosynthetic pathway here. Starting with cholesterol, you can make progesterone, and then you can make something similar to testosterone, and then from testosterone you can make estrogen. Males need estrogen in their brains in order to speak, because that's part of the neurotransmitter program of the brain. Every brain requires estrogen. So males are going to have to transform their testosterone, their available testosterone, into estrogen and then speak. Okay, so that's that little detail right there. And here we have a much more schematic looking diagram that shows us all of the different parts right here. And we go from the testis out into the epididymis through the 18 inches then of ductus deferens. Here we're on the back of the bladder. This is the urinary bladder. We're coming around the back side of it, and we're picking up fluid from the seminiferous tubules. Most of the fluid comes from that. And then we're in the context then of the prostate gland. When the prostate gland, which is a very muscular gland, contracts at the time of ejaculation, prostate, then it's going to send the entirety of the seminiferous fluid the prostatic fluid and the sperm from the testis, they're going to be coming out this way. You can see that the most significant part of the erectile tissue here in the shaft of the penis is the corpus cavernosum, whereas the glans penis is corpus spongiosum. Okay, so that concludes that portion of the anatomy right there.